I am Donna Young, and even though I am the National Event Supervisor for the astronomy event, I am presenting the middle school division Reach for the Stars event for Dusty Schroeder, who is the National Event Supervisor. I'm doing it as a favor for Dusty. So the focus for the 2013 Science Olympiad Reach for the Stars event is stellar evolution and the electromagnetic spectrum. And I, as most of you know anyway now, I am the lead educator for the Chandra Education and Public Outreach Office, and Chandra has been supporting and helping sponsor this event for the last 12 years. And Dustin Schroeder, who is now the National Event Supervisor, he became the National Event Supervisor last year when Linda Winter retired from the event. But he was my co-event supervisor for astronomy, so we have been supporting Dusty and astronomy and Reach for the Stars for several years now. This webinar will be posted on the Chandra website under Education, and it is one of the resources to go to for content and image information. And it has a lot of materials that students can use for resources. Also, this event is supported by the American Association of Variable Star Observers, also in Cambridge, Massachusetts. I am part of the staff for AAVSO, and on their main page under Variable Stars, if you go down to Educational Materials, and then you will see that Science Olympiad is listed there. And under that menu, you will find posted the 2002 event from Orlando for astronomy and Reach for the Stars. And there will be a link to this webinar from there also. And also the PowerPoint for this presentation will be posted there as well. And where it says Variable Star Astronomy, that is an entire curriculum that was, I was the author of that curriculum, and Chandra helped sponsor me to put it into a PDF format to be posted on the AAVSO website, free for anybody to download and use. The event description for Reach for the Stars this year is that students will understand the process and properties of stellar evolution, and especially how these deep sky objects are viewed with different parts of the electromagnetic spectrum, because different processes emit different types of radiation. So if you really want to understand how a deep sky object, how it functions, you really need to see what's going on in the optical and the infrared and the ultraviolet, radio, and the X-ray to get a complete picture of what's going on with all of these deep sky objects. Each team member may bring only 2 8.5 by 11 pieces of paper with information written on both sides of those 2 sheets of paper. Any information, any graphs, anything that you want to have on those 2 pieces of paper, you can bring to the competition. It also says to bring a red flashlight and a clipboard. However, that is only if you are in a planetarium or a sky lab or some kind of star lab or some kind of planetarium venue, and that does not happen very often. It's usually just in a regular lecture hall. So you need to look to see if a planetarium is going to be the location. If not, you will not need the flashlight and the clipboard. There are 2 parts to this competition. First is the constellation and star and deep sky object identification, knowing how to indicate them on different varieties of star charts. Part 2 is understanding stellar evolution, the different stages from protostar, stellar nursery protostar, to main sequence star, to red giant or super red giant, planetary, nebular, and white dwarf, or type 1a supernova event or type 2 supernova event, which will lead to neutron stars and pulsars and black holes, a basic knowledge of the different mass sizes of stars from formation to destruction. Also, the spectral classification of stars is very important because that's how we know their stage of stellar evolution, by their spectra, and how they are placed on the Hertzsprung-Russell or HR diagram. The electromagnetic spectrum itself, which means that you need to study images of the deep sky objects in every wavelength that you can find. And then the relationship between stellar temperatures and radii and luminosities, and again, that is, you can do that by understanding the HR diagram and the radiation laws. So these are the deep sky, the constellations of stars and the deep sky objects for the 2013 competition. In black are the constellations that you are responsible for knowing. In the blue are the major stars that are part of the common asterism that you see for that particular constellation. And in the red we have the deep sky objects, and I have placed them in the constellation that they are found, because constellations are used mostly for directions. And you can see, for instance, in Centaurus, I've listed Proxima Centauri as a deep sky object. It is, of course, a star, but it's not a major star that's part of the common asterism for that particular constellation. Therefore, I have arbitrarily put it in a category of deep sky object. So some of these constellations have a prominent star. Some of them just have deep sky objects, and some of them have both. So Aquila, or Altair, that constellation contains Corot 2a, which is a star with a planet forming around it. The planet, though, is it's only 3 to 5 times larger than Earth. It is within 3 to 5% of the distance from the star than the Earth is from the sun, so it's very, very close. And this thing is getting just bombarded with X-ray radiation, and it is evaporating at the rate of about 5 metric tons per second. So probably this planet does not have a very long life expectancy. Also, there is SS433, which is an X-ray binary, actually. It is a black hole that is eclipsing with a companion star. Aquarius and the Helix Nebula. The Helix Nebula is a planetary nebula. It is the result of a red giant star that started off sort of about the sun did. The sun will eventually form this same aplanetary nebula and a white dwarf in the center. That's the end product for sun-sized stars. Auriga with Capella, which is the chariot of Orion. Boötes, Arcturus, the shepherd, and Arcturus is a red giant, and that is an image of Arcturus. Canis Major and Canis Minor, which both have very, very bright, prominent stars. Well, Procyon is the bright star in Canis Minor, and Sirius is the most prominent star in Canis Major. And what is interesting about those two stars is they both have a white dwarf companion. Carina, Eta Carinae, is a hypergiant star, a seriously massive star that is extremely unstable and could go at any minute, astronomically speaking. And hypergiants are very rare because there aren't as many massive stars as there are mid-sized stars, and not as many mid-sized stars as there are low-mass stars. It's sort of like the food chain. And the top predator, there's a few of those, and there's a whole lot of producers at the bottom. So you don't find these two very often. However, they don't last very long, so you do see a lot of remains of them.